modulators, not for sake of empathogenic states or psychedelic states, but to try and keep those dopaminergic neurons online to offset dementia, because that's what the question's about. In fact, there's a Nobel Prize-winning neuroscientist at Columbia University, whose name I won't tell you, or maybe I will, who, when I went to visit his office, chewed no fewer than 5 pieces of Nicorette in the course of a half an hour. And I'm like, what's going on? He's got a Nobel Prize, but this looks kind of pathologic. And I said, why? And he said, well, the nicotine is to offset age-related loss of dopaminergic and cholinergic neurons. I thought, really? He's like, yeah, when I quit smoking because I want lung cancer, but this is anecdata, I'm not suggesting you do this. I think there are a number of things that we can do, but protect those neuromodulators, keep perfusion, that is blood flow to the brain, strong. There's a case for cardiovascular exercise, and it really does seem that exercise that engages the neuromuscular connections more than cardiovascular exercise. So not just resistance training, but anything that involves coordinated bodily training, learning new physical skills, dance, etc., really does seem to offset some of the loss of cognitive functioning in adults. So it's kind of interesting that physical exercise is great for cognition, and probably cognition may or may not help physical ability, but one probably can imagine why there's a bidirectional relationship there. Your nervous system doesn't really distinguish between physical and cognitive. It's all working as a bunch of functional units. I could go on and on about this, but hopefully that at least gets the gears turning around some things that perhaps you've heard about and some things that you haven't. And we'll do an episode on dementia and offsetting dementia in order to get into some of the fine details. Okay. Can we increase our willpower just like training a muscle group with your research into the AMCC? Ooh, I'm so glad that you mentioned the AMCC. I think of all the new areas of neuroscience research that are out there, I think the anterior mid-cingulate cortex is one of the most interesting structures and areas of research nowadays. You know, I think if I have my way, then not only will most people have heard of dopamine and the amygdala. I guess you need a Star Wars character named after your brain part. Isn't there one? Right. I only saw the first 3. I'm of that generation, but isn't there an amygdala or something? Yeah, right? Don't leave me hanging here. Is there or not? If I'm wrong, just say no. Okay. Anyway, the amygdala, thanks. The amygdala is a brain structure that is involved in threat detection and novelty detection, not just threats. The anterior mid-cingulate cortex is an area of the brain that we know is activated. Well, let me tell you the best experiment. The best experiment was done, in my opinion, by a neurosurgeon at Stanford, Joe Parvizi. He's probing around in people's brains. They got a little piece of skull missing. He's stimulating in the brain. He's asking them questions. How do you feel? What's going on? How do you feel? What's going on? And he's got this electrode in the anterior mid-cingulate cortex. And the patient says, I feel like something really bad's gonna happen. Like a storm's coming. It's like, okay, well, we can stop stimulating. He's like, no, I'm going into the storm. It's like, oh, that's interesting. Stimulate a little bit further back, just by a millimeter or so, completely different subjective experience for the patient. That's interesting. Get a different patient in there, map to the anterior mid-cingulate cortex, stimulate, and the person says, I feel like I'm gonna get out of my chair and I'm gonna do something hard. Wild, right? This is prior to any knowledge of what the anterior mid-cingulate cortex is doing. Make a long story short, people who successfully overcome a physical challenge, a cognitive challenge, that learn a new skill, that successful dieters, I don't really like that term, their anterior mid-cingulate cortex grows or becomes more active under conditions that challenge the anterior mid-cingulate cortex. So this brain region seems to be the brain region that puts us in a forward center of mass, physically and sort of cognitively and emotionally. I often like to think that the nervous system, as sophisticated as it is, and psychology as sophisticated as it is, can be binned into kind of 3 categories. Things that we like to eat or don't like to eat, or can kind of be binned into yum, yuck, or meh. That's kind of what the nervous system has to do, because ultimately you have to decide, do I want to go toward it, so-called appetitive behavior, do I want to get away from it, or I don't want to do nothing. People were either like yum, or some cases yum, yuck, or in some cases like ugh, or like meh, right? Yum, yuck, meh, yum, yuck, meh. This is the sort of 3 tributaries that we have the option of moving down, not moving down, or moving away from. So the anterior mid-cingulate cortex, because it has inputs from so many different areas and outputs to so many different areas, it can access circuits related to dopamine, norepinephrine, it can access circuits related to memory and context. It's a hub. It's a hub that, by all views, through all lenses of the existing research, suggests that anytime we do something truly challenging, in particular things that we do not enjoy, this is key, the anterior mid-cingulate cortex undergoes some sort of plasticity. Everything in the research data now points to the idea that the anterior mid-cingulate cortex is the seat of so-called willpower, which is linked to concepts like tenacity or grit, and et cetera. And what I love about this research is that it comes from a bunch of different areas: human brain imaging, brain stimulation, et cetera. Here's what I don't like about the reality, but that we all need to accept, which is that the anterior mid-cingulate cortex is modifiable by experience, by leaning into challenges at any stage of life. That's great. We talked about that earlier, plasticity. But lest we forget, plasticity goes in the other direction too. It seems that when we don't engage in challenges, that the anterior mid-cingulate cortex, it doesn't atrophy, but it undergoes sort of a downshift in activation. Now, here's what's really, really interesting and relates to the previous question. The anterior mid-cingulate cortex seems to be especially active at baseline and available for plasticity in what are called superagers. Superagers, we've all heard of blue zones. The superagers are these people they don't just exist in blue zones. They're spread around the world. These are people that seem, at least by cognitive measures and other physiological measures of the body, seem to age extremely slowly. So they shouldn't really be called superagers, right? They should be called super non-agers. Anyway, the anterior mid-cingulate cortex seems to be hyperactive in these superagers, as they're called. And so it seems that not only do they maintain cognitive function later in life, but that seems to be related to their regular engagement in challenging things. So remember, for so many years we heard, okay, like nuns don't get dementia, and then there's all sorts of things you can imagine could be related to that. And then we're thinking, maybe it's crossword puzzles. Maybe it's crossword puzzles. Maybe it's hanging out with other people. And then that person down the street, and she's cycling on the weekends like crazy, and she's 90, and she looks like she's 50, and she's sharp as a tack. It's probably leaning into challenge on a regular basis. Leaning into challenge on a regular basis, as opposed to one specific cognitive or physical thing, which means that if you love cycling, or you love the cold plunge, or you love a certain form of exercise, it's probably not doing that much for your anterior mid-cingulate cortex. But these superagers also live longer. And so there is this notion that because the anterior mid-cingulate cortex has connectivity to a lot of areas of the brain and body, that it is somehow linked to the will to live. And this is being examined now in so-called terminal cancer patients, so-called, terminal cases. I don't like the language, because there are these amazing instances, and physicians and oncologists have known this for a long time, that when people decide they're gonna fight cancer, they don't always win that fight, unfortunately, but oftentimes it's the people who insist on fighting it psychologically, that they won't give in, that end up still living more months, more years, and in some cases, putting the cancer into remission with, of course, other tools, right? I'm not saying you shouldn't use other tools to combat cancer. It's a very interesting structure, relates to the question on dementia. Hopefully that was informative. Julian, thank you. How would you recommend shift workers minimize the effects of disruption to their circadian rhythm? Oh, this is so important. You know why? Because like right now, 9:40 p.m., we're kind of doing shift work right now. Most people are on a shift work schedule now in the world. This is true. We think of shift workers as only the people who are up in the middle of the night and sleeping during the day, but most people are doing shift work. The criteria for shift work is at least a 2-hour variant, at least in the US, a 2-hour variance in the sleep-wake cycle, more than 3 nights a week. Anyone here go to sleep every night, same time, wake up every morning, same time, never stay up later than that, more than 2 nights a week? okay? Most people are doing shift work nowadays. They're just on their phone or they're on their computer. And I'm not going to argue that's, you shouldn't. Many times that's me as well. So here's what we do know. And we did a whole episode on shift work, but I'll try and summarize some of the key points. You want to have your cortisol elevated early in the day and then subside across the day. That's the ideal pattern of cortisol release. Cortisol is a great thing when it's high and then tapers off from early day into the later day. It's a bad thing if that cortisol peak is shifted late. That cortisol peak is coming every 24 hours. You don't have a choice. Question is it going to be early day or is it going to be late day? Late day cortisol peaks are associated with depression, anxiety. This was done by my colleague David Spiegel and the great Robert Sapolsky at Stanford, a study about that. Robert, another great beard. Amazing. And I always thought it was to blend in with the species that he studies, because he was like the baboon guy, I haven't quite figured out how to master that one, like the cuttlefish look. But working on it. Maybe I just have to, no, never mind. There's a story about, remember the earlier story? The maid, anyway, the cuttlefish maid, anyway, never mind. Again, this is why I don't like to speak too late in the day. I get myself into trouble. But the point here is that having that cortisol peak early in the day sets you up for mood focus and alertness, immune system function in a really great way. Shift workers have a serious problem, which is that late peaks in cortisol are kind of paramount in all forms of shift work. And so what you need to do is to put yourself ideally in lighting conditions that limit the amount of blue light coming in at night or when you're doing that shift work. Now, you have to do your work. And I think in the next 2 years, if I have my way, one idea that I'd like to kind of embed in people's minds is, we hear a lot now about how hyper-processed foods and highly processed foods are bad for us, sort of empty calories. What are empty calories? It's foods that are very calorie-dense but micronutrient poor. Right? That's what it really is. It's also the quality of food issues, and people get, like, let's please not have the seed oil debate. It's like people get really into this, and it's unclear to me still, and okay. But we sort of think of empty calories like alcohol, sugar, et cetera. Calorie dense, micronutrient poor. Light can be viewed in much the same way. These days we live in a very blue light rich world. Lot of blue light, so short wavelength light, blue light, UV light. And by the way, in sunlight, especially down here, it's very UV rich, blue, which is great during the day, especially when it's offset, when it includes long wavelength light, full spectrum light. By the way, for everyone that's obsessed with red light, and I love red light and red light therapies, remember the best source of red light is the sun. It's full spectrum light. It includes red. It's just there's a bunch of other stuff in there too, so it doesn't look like a red light panel. That said, if you are going to do shift work, one of the best things you can do, and it's been shown to reduce cortisol levels at night while you're doing that shift work, is to filter out some of the blue. So that is a use case for blue blockers, or even for glasses that put you into more reddish conditions, provided you can still do the work you need to do safely. You will see a dramatic reduction in cortisol under those conditions. This blue and UV pathway picked up by a certain set of neurons in the eye, called the intrinsically photosensitive melanopsin cells, et cetera, is a real thing, and it's designed to activate you. This is why so-called seasonal affective disorder lamps, SAD lamps, are basically bright blue, white-ish light. So when you're doing that shift work, if you can get into red or orange or amber light conditions, that's great. You can do this very inexpensively, by the way, by just getting some party lights. It doesn't have to be any fancy red light. We're not talking about red light panels. The other thing, of course, is when you get back to your non-work environment, you need to do some work to think about when is best to sleep, when is not best to sleep. Is it best to sleep all day and be up all night, or get that sunlight in the morning? And I talk about that in the shift work episode. And I'm tempted to go down that rabbit hole now, but I would just encourage you to take a look at that episode. And I'll just cue you all to a resource. The HubermanLab.com website allows you, thanks to our wonderful engineers, to put in multiple topics. So you could say shift work, red light, or shift work, dopamine or shift work, sunlight, and it will take you to the exact timestamps across all the episodes where those specific topics occur. It's all zero cost, as opposed to having to go and peruse all these different episodes. A lot of people have said, why not shorter episodes? It's like, well, the idea was to create a library of information that now AI and better engineering of websites can allow you to just pull the relevant information just like you would a book. Well, I used to go to the library. For those of you like me old enough to remember, you actually took this thing called a book off a shelf, you Xerox copied it. In any event, it was very archaic and very expensive, and you'd always get the margin of the book in the middle, like the spine. It sucked. Now you can go to the website and just get that information, and then we also just launched an ai.hubermanlab.com website. Again, it's all zero cost. You can just say, hey, what should I do for shift work? But I wanted you to come here tonight, so I didn't tell you that until you got here. No, I'm just kidding. Okay. And there are a few other tools about adjusting eating schedules and whatnot for shift work, but hopefully that gets you going, Julia. Thank you. What's the difference between NSDR and meditation? Thank you for this question. I am a huge believer and proponent and practitioner of NSDR, non-sleep deep rest. What is non-sleep deep rest? Well, to be fair, Yoga Nidra, which translates to yoga sleep, is a 1,000-year-old practice, thousands of year old practice in which you lie completely still, keep the mind awake. You're not thinking in a structured way. It's more of a body scan, directed relaxation, et cetera. I discovered this in 2015 when I was doing some research for a book that I still can't manage to seem to finish on trauma and addiction. And I have a friend, very talented trauma therapist, who's managed to help people with all sorts of addictions. He'll be on the podcast in the not too distant future. And I went down to this clinic in Florida, and everyone there spent the first hour of the day doing Yoga Nidra. I thought, well, this is pretty wacky. I was still in my pure science, quote unquote, pure scientist, naive scientist lens. And I thought, what is this about? And he said, well, so much of addiction is about an inability to regulate impulses, to deal with agitation, especially in the early days of trying to get sober or being sober. And it just helps people learn to regulate, self-direct their nervous system in terms of self-directed relaxation. It also seems to help with their sleep. It also has these components about time and sort of, because he said, it's kind of interesting. If you take a step back, if you can tolerate craving for a second, you just did it, so why couldn't you do it for another second? Why can't you do it for another second? It's not as if it necessarily increases linearly or over time. So, what's going on? And so again, sort of our ability to realize and regulate our states across time, and to realize there's this funny thing where when we feel terrible, we think it's gonna go on forever, and when we're happy, we're like certain it's gonna stop. There's like kind of asymmetry in our nervous system that we don't understand. He started talking about Yoga Nidra really seems to help addicts recover and stay sober if they do it regularly. I thought, well, this is cool. What is it? I'm a neuroscientist. We started studying it in my laboratory. We discovered that the brain goes into these states during Yoga Nidra that are similar to sleep. Body still, mind alert. And that seems to be very beneficial, maybe even accelerates neuroplasticity and learning, and indeed there's evidence for that, and there's evidence that Yoga Nidra from a laboratory out of Scandinavia, not my laboratory, showing that it can increase dopamine levels in the striatum, basal ganglia, by up to 60% using human positron emission tomography imaging. So we're talking about how to increase dopamine through non-pharmacologic means. This is something about body still, brain active, very, very powerful way to do that. I made up this term, this acronym, non-sleep deep rest, because I have tremendous respect for Yoga Nidra and the yoga traditions, but I was concerned. For a lot of people, unfortunately, when they hear Yoga Nidra, it sounds esoteric and they're not going to approach that practice. Also, Yoga Nidra includes intentions and some things that are a little bit on the mystical side, and I knew I was going to take some heat for it, and I feel badly about it, but that bad feeling is offset by, I think when you call something non-sleep deep rest, it tells you what it is, and then more people are likely to come to the practice, and I felt like it was worth, kind of putting myself, jumping on the grenade for that one. So, non-sleep deep rest is very effective at restoring cognitive and physical vigor, and can indeed offset some degree of sleep loss. It also gets you better at falling and staying asleep, and it's very simple and very easy to do, and it's zero cost. And if you want to try it, you can go onto YouTube and put NSDR. My last name, there's a woman named Kelly Boys, B-O-Y-S, who has a much more pleasant voice than mine, who does them as well. These are all zero-cost protocols. She's also in the Waking Up app. And there are many of them. Kamini Desai is another person who has wonderful Yoga Nidra scripts. So you can find these things, and they're really about 10 minutes to 20 minutes, sometimes 30 minutes long. You can do it for an hour, but most people won't do that consistently. You don't have to do them every day, and they're very, very effective at restoring mental and physical vigor when you're feeling depleted and at getting you to be a better sleeper. So I figure that's a zero-cost tool that is grounded in good mechanistic science and makes sense logically, so why not? Meditation, typically, and there are many different forms of meditation, but if you're, let's just say kind of standard, if there were such a thing, third eye meditation, closing your eyes, focusing your concentration on a point just sort of at your forehead, concentrating on your breathing, redirecting your attention to your breathing if your attention drifts. We know based on work from Wendy Suzuki's laboratory at New York University and some work out of the University of Wisconsin, can improve memory, can improve focus, and does seem to have some stress offsetting effects, but it's more of a focus exercise as opposed to an energy replenishing exercise. Now, some people meditate and feel better afterwards, they have more energy, but then it's sort of like, well, compared to what? I don't think that's the major effect of meditation. And while we're on these topics, I should just say that self-directed hypnosis of the sort that my colleague David Spiegel studies is more about solving a particular problem. So hypnosis is more about engaging neuroplasticity. Remember earlier we said that neuroplasticity in adulthood can be activated by focus followed by rest. It seems that in these self-directed hypnotic states, the brain enters kind of pattern of activity in which neuroplasticity can be accessed more quickly, we think, because the brain is both focused and relaxed in a particular way, merging that focus and rest state. And of course, the hypnotic script is not about getting you to do crazy things on stage. That's stage hypnosis, but self-directed hypnosis is, for instance, smoking cessation. By the way, the success with smoking cessation from hypnosis is far greater than the cessation with smoking from pretty much any other protocol. But unfortunately, it has the name hypnosis, which makes people think about stuff that people do on stage that's kind of wacky. So we need a new name for it, because unfortunately, names are a problem. Names can be differentiators as opposed to integrators. They don't bring when people say, I'm gonna hypnotize you, or you should try hypnosis, people are like yum yuck meh, they're like yuck. So, by the way, does everyone here remember how you know if you're highly hypnotizable? Do you know that the Spiegel eye roll test, it's not what teenagers do. David Spiegel and his father, psychiatrist, discovered the clinical application of hypnosis. It's a clinically approved tool. There's brainstem neurons that cause elevations in alertness and focus, and they're associated with moving the eyes up. They're brainstem neurons that close the eyelids and push and essentially drive the eyes down, that are associated with parasympathetic states, which is why you go like this when you're tired. You're out there, I'm sure. If you are capable of keeping your gaze upward and closing your eyelids, you score on a particular end of the so-called Spiegel eye roll test, which makes you highly hypnotizable. Because that state of hypnosis is one in which you're alert but very, very relaxed. So if you go to Spiegel's laboratory, they're gonna look at you and they say, look up at the ceiling and then close your eyelids. And if you can still see the whites if they still see the whites of your eyes as your eyelids close, well then you're in the highly hypnotizable realm. Kind of interesting, right? This is all nervous system related. And you can see this stuff this is like real clinical tools. Okay, how do we stop ourselves from mindlessly scrolling on our phones? Hard questions. I didn't look at my watch because I'm bored. I'm just thinking, how much time do you have? Well, on the way here to Australia, Rob, who you met earlier, my friend and podcast producer, he said, okay guys, everyone's deleting social media from your phones for the whole trip. The whole trip. And I'm like, I don't know if I can go on this trip, Rob. No, I'm kidding. We have one guy who's kept it on his phone so that we can post things, and we continue to. Honestly, I think that's what it takes. If it's social media that you're scrolling, I think you should do a delete and reinstall. If I'm honest, a delete and reinstall every day. Because I think, and then you have to limit the amount of time. And one of the members of my podcast team experienced this. He said, I just picked up my phone a minute ago and I went to hit the Instagram tab and it wasn't there and I know it's not there. And that's where I say, yeah, at some point it becomes more compulsive than addiction. These are just reflexive behaviors. It's like walking to the refrigerator. I did it every day of my life, all day. I walk into people's homes and just look in the refrigerator. I don't even know. I get into people's cars, I look in the glove box. I just do this. I'm kind of looking around. I'm not gonna steal anything, but it's like the teenage boy in me, I just kind of walk in, I'm gonna open your refrigerator. So I think it gets to the point of reflexive and it's compulsive and it might be addictive, but it can't be good when it's like that. But I think social media can be really useful. So I think if you can set timers, you can try graying out the screen, getting rid of the color thing. There's all this stuff, but I think if there are particular apps that you're struggling with, I would just delete them from your phone and do a reinstall, because that's enough of a behavioral barrier. There are enough steps involved, enough sequencing to put the thing back on there each day and each time, maybe twice a day, that you're going to vastly reduce your use. To be honest, I think that's probably the best way to do it. And there are probably people in this audience that are thinking, this seems crazy. Just don't turn it on. Just don't open it. And look, if I was 65 years old, I'd say that too. But it doesn't work that way for certainly the younger generation. It doesn't. And I know this because I gave a talk at Santa Clara University a few years ago, and I was talking about limiting social media use and phones. And this kid came up to me afterwards. He said, "You don't get it." It's like, you're back then I was 43. He said, "You don't get it." He said, "For you, the phone was a thing that you integrated into your post-90s high school life. You watched The Breakfast Club or something." I don't know how he knew that movie. I was like, "You're right, I did watch The Breakfast Club a bunch of times." And he said, "But for us, it's like life." I was like, I rolled my eyes and I thought, wait, no, listen, I'm gonna listen, because no one knows what it's like to be 16 years old or 24 years old in 2024, unless you're 16 or 24. I'm like, okay, here we go. Listen, he said, when my phone powers down, I feel the energy drain out of me. And when it comes back up, I feel life energy come back into my body. And I thought, oh my goodness, we are hosed. But that's the reality. And I'm of the mind, I was a camp counselor. I worked with at-risk kids. I was a wild kid. And you learn something, especially when you work with kids like me. When I was a teenager, I was a hellion, is be a channel, not a dam. You cannot block this system that's emerged. This is here and it's here to stay. So I think things like deleting the app, is putting it back on there, is the only way to go. And we have to listen. I think we have to listen, understand that we, after all, adults created these technologies and these kids are using them, and I don't think we're gonna see a reversal. I don't. So we have to really, I think that what he said to me, as scary as it was to me, I think reflects the reality. It's part of their life energy, it's part of their connectivity, and we're gonna have to come up with better tools. And I doubt those.